believe so. Okay.
I feel like it should be. Oh, you made the mic. Mic is live. Oh, mic is live. Okay, we are live. All right. So I also noticed I don't have my hat on. Everybody can see my glorious long hair. Should I put my hair in a ponytail and? Yeah.
You can see the mane.
I see that. Oh man, the old man with the hair. All right, yeah. Maybe we'll just. I was so tired when we did this on Tuesday, and that last bug that we had, we broke the code essentially when we started making those changes, which I'm not surprised about, right? But hiding the mutexes in those little functions caused the logic to change essentially. And I didn't catch that until that. And plus, that API I was calling that was returning a nil pointer because of the timing of things. You could see how inexperienced I was 8 years ago, where my fix for that bug was to wait for that to sort of finish.
Okay.
Right? But it really wasn't the right way to solve that problem. And looking even deeper, realizing that what I should have been returning is so. Let me bring up the code.
Yeah, that's.
It's just a bunch of. It's just bad. Where is this TCP?
Yeah.
So I had a few bad things going on here, which was sort of interesting. The when I talk about pointer semantics creating side effects, this is what I'm talking. Like we saw some really weird side effects of some concurrency and pointer stuff. Oh, dude, I see a little dot 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 there. Make copy of all the. Oh yeah, I'm afraid to change that until. So there was the initial bug on this was returning the address. If we were to look at the original code here, it was no. I mean, it was using t.listener dot address.
Okay, that was that piece. Okay.
And the problem was that the listener was nil because we hadn't established it yet. Because I took out the code that was waiting for everything to get established.
Okay, so it was like.
So that's the panic we were seeing. But it was manifesting in the stack trace in a really weird way. So it wasn't obvious. But this really was a silly thing to do in the code. One, because this could be nil, and now it suddenly was because we weren't waiting for everything to get established.
Premature.
But in new, when we first come in new, where is it? We do this resolve where we get a pointer to a TCP address. So we sort of have one already. Like that's the one I should have been using from the very, very beginning anyway. Now, this is still a pointer. I have to look at that because this thing as an API returns the TCP address as a pointer, which always tells me that this is some sort of API, right? And if I look at this, it looks like data, but it does have a pointer semantic API. I don't know what an IP address is, but this is when I go a little crazy sometimes because I feel like this could have just represented data. Like I feel like, and I don't know enough, but I don't know why pointer semantics are being used here, other than they built an API that can mutate this value directly. But from my perspective, this really represents data. Yeah, I can even look at it. I've even looked a little bit at the API around it. This could potentially, for me, be a data semantic mistake.
Okay.
But if you look at the address API that I have here, that we just saw, I'm using the interface. So this could still be nil. Well, it can't be nil in the sense that we are establishing it in new. So by the time you would ever call this, we sort of have one. We're also sharing it through the scope of an interface. Okay, and so we're sort of going to get away with it, but it bothers me that there's pointer semantics being used here because when I really look at it, it represents data. It doesn't represent. There's an API around it, but I wouldn't consider it. It represents a TCP address, like, you know.
Yeah.
So we could get in some trouble there. But the good point is that we have one, or we didn't even get past new. So that solves sort of that problem that we were having. Also, the way I was bringing up our test app was when I looked at it a little bit, right? I was just specifying :0, which really I should be specifying an IP and a port. And if we use the IP address of all zeros, we're basically saying all interfaces on port 3001. Now, so that's the first bug. That's what what was being manifested is we were trying to access something off of listener, which was nil.
Oh, okay.
Never,
so that was the
never
nil
in a
pointer.
million years that was going to happen.
Got it.
And that was again because we didn't wait for this go routine to suggest that this happened, and that we assigned this listener back to essentially T.
Got it.
Right?
Okay.
So at some point, in fact, I don't even see us doing it here right now. At some point, when are we doing that? I don't see any. Interesting. I don't see any situation right now, and I know this code was working. Yeah, where I had to save it. Okay, like I said, the other code, even though I've used that in early days, some production code, right? I'm starting to now see that. I don't know if I need to. I'm going to get rid of that and see what goes red for a second. All right. So you got TCP listener, reset. Let's just say we got rid of that for a second. Oh, the start listener is here. Okay. So we are using it. I just hit it into the start TCP listener. And we're using it to determine if the listener exists or not.
Got it. Okay.
But what I'm super interested in is if we're ever using this pointer directly, which right now I don't see where it's being, because here we return it. See, like we construct it, we return it. We assigned it here, but I never really, oh, here's stop. Stop did call close on it. So this is the only place, and we haven't finished fixing this code.
Okay.
Here's the place where we use it. It's like, why do I need to keep it? Because somebody might call stop, and
then
we
we have
want
to
close it.
Okay.
Okay.
Yeah.
So that's what I was looking for. It's like, because at that point I could just use a Boolean flag or something, right? To suggest that we've got a listener. Okay. So when we built all these little support functions, which again, we have to move to the bottom. Okay. Where we took the read and read unlock and we said, give me back this value. We had the lock and unlock. We can close it on the reset. Another lock unlock on the start where we construct this thing. All right. We broke all the original logic in here because we started to isolate some stuff. So let's walk through this real quick again and you'll see.
Okay.
So we're checking to see if somebody's trying to call start more than once, right?
Okay.
Mohammed, I see your stuff here. Should we always in the beginning of the loop call the listener? Should it be one time? And we're going to walk through the logic one more time now that we're together. So did we call start twice? Okay. If the answer is no, then I have this wait group here, which is letting me know that we're going to have this go routine in flight. And when the go routine dies, we're just going to log that we're shutting down, and I'm going to decrement the wait group from 1 to 0 as a synchronization mechanic to say we're now down.
Got it.
Now, I have a loop here that starts a listener. The idea of this loop is if we have an error that's not temporary and we're not shutting down, we need to bring the listener back online, right? Or we're a dead service. We're a dead service. So this has to be in a loop for our ability to restart the listener, right? So if I change this label to start listener, say I change the label to start listener, all right? Then I know that anytime I go to this label, the idea is that we're looking to restart the listener. Now, this code is wrong. This shouldn't be a break. This should be a continue. Because what I want to do is continue back to the for loop, not break out of the for loop.
Okay.
So, but just keep that for a second. So the idea is, okay, start a listener.
Yeah.
At this point, I don't know what to do here other than like the panic here, but we weren't getting any panics here before, right? So we start our listener. And then we logged here that we're now waiting for, thank you, we're waiting for socket connections to come in. So now we have a second loop, okay, which is to, I called it end accept, but let's just call this the accept loop, all right? And the accept loop is all about one go routine accepting one connection at a time. We don't have to make that concurrent. So we block. Let's say we both hit enter to get a connection. Well, we're going to have, one's going to beat the other. So we accept the socket connection. We check to make sure we didn't have any errors. Let's not worry about that right now. Then I'm looking to see if we were asked to drop any new connections, like we're in some sort of rate limiting thing.
Okay.
Okay, we're not doing, actually it's not rate limiting. This is the rate limit. So, oh, I had an API that allowed us to sort of drop connections. I don't know why I ever added that. Like some dial that would just start dropping everything. I must have been in a situation where I needed the ability to just not accept anything at any given time, right? So this confused me last time too. So if I just do this for a second.
Was that what, I'm trying to remember what it was. When it would drop if you were inactive?
You see this API call, drop connections?
Yeah.
For whatever reason, I added an API call here that allowed me to tell this system not to accept any more connections.
Oh, okay.
Right? Okay. Drop is probably the wrong word. It's really like don't accept any more connections.
Like stop connections or block connections.
I'm gonna get rid of this, man, because this makes like zero sense to me, bro. For like anything that I'm doing. So let's just get rid of that. I don't think this is adding any value to at least where we want to be. Okay. Then we had this rate limiting stuff, right? And I would argue again for what we're doing right now on the rate limiting side. Like, do I really need to worry about sort of rate limiting? Let me go. Like right now, it's just making the code more complex. Where does this type come from? Is this something that I built myself? Oh yeah, I had this. Oh, it was a function that we would call on the. I'll fix that in a second. Let me see what happens. Like, I just want this code to be a little simpler. So if I get rid of this, I get rid of. Like I was doing my own sort of rate limiting on what time was it. And if I was going to add rate limiting to this thing today, there are packages that just do that really, really well. Like it doesn't make sense to sort of code that yourself anymore. Maybe like 8 years ago that didn't exist or something, you know? But it doesn't make sense to sort of do that yourself anymore.
Got it. Okay.
So I think we can get rid of this altogether. And again, just sort of try to simplify. We'll fix all the things that are gone red here, which would be pretty much set the job connection true. Why is this test? Like I have a whole test here to test if I could drop connections. Let's just get rid of that. And I have a whole test here to test some rate limiting.
Yep.
I don't need it. Like, again, I would do this so much differently anyway at this point. Okay. So let's go back to our logic here. So we have our start listener loop. Hopefully we never have to go back through there. But here's the accept. Now, if the accept fails, I check to see if we're shutting down. It could very much be because we closed it.
Okay.
We called shutdown. We closed it. So it failed. So I do the reset anyway. And on this case, oh no, on this case, I want to do a break, right? In this case, what I'm saying is break out of this loop. We're done. We're shutting down, right? And the reset essentially called close, though ideally we already called close because we were telling it to shut down, right?
Yeah.
But there's any number of reasons why this failed. One could be because we called close.
Okay.
So we do want to break out of the start listener loop because we're done. Like we're done. Then we're going to check to see if it's a temporary error.
Yeah.
So if it's not, so if it is temporary, we just run continue, which puts us back here, and we just say, oh, we couldn't accept that connection. We're just going to keep going.
Okay.
But if it's not temporary, then I'm breaking out of this loop. Okay. When I break out of that loop, what happens? I come right back here. Now, we could make an argument that really what I want to do is a continue here. Then I can get rid of this. So you can do a break label, but you can do a continue label. And so here what I'm saying is break out of our loop, but this is continue back to the start listener.
Got it. Okay.
Right?
And then it'll start from here again.
Yeah.
And continue.
Yeah, and we can get rid of the other label. So nice, right? Or we're just going to continue back sort of the top of this. Now, because of that, I don't even need this continue anymore because there's nothing else. Oh, no, I do need idea. It's wrong. It's the wrong continue, right? Now from here, I'm going to come back to the top, and that's the error case. And if there is no error case, then we're just going to add the connection to some other code that we haven't looked at yet.
Got it.
Okay, to our manager map. So by getting rid of the drop and getting rid of the other thing, this is much cleaner now, isn't it?
Yeah.
Like we can see what we're doing. And hopefully, Mohammed, that makes more sense to you now. I just getting rid of the code we didn't need didn't help, and getting rid of the second label helps too. So it's either we're breaking out of the outer loop, or we're continuing back to the outer loop, or we're just going to stay in the inner loop accepting connections. Okay, and now with this one code change, there's more we have to do here, right? If I go back to my hack program, I did a couple of things here.
Okay.
I'm only going to listen on port 3001 for new connections. So we call new. I called start with the stop. And then I do this 2 times where we attempt to dial a connection into our server to further close.
Okay.
If we get the connection, we break, right? So I'm trying over and over again just in case the server's not ready yet.
Okay.
That's all we did there.
Yeah.
Though technically, because we're not waiting for start to happen, right? Like this should happen fairly quickly. I can even probably knock that down to 5. We'll see how fast it does it. Then we're doing the basic send receive. Then I put it in a loop so we can establish a second connection to make sure the loop is working.
Got it. Okay.
And then when we return nil, we should call stop. And we should see in our logs at least the connection. Now, I remember seeing something in the log I didn't like. So let's run this again. Make hack. So this is cool, right? This was an immediate connection. Try connection number 1. So you could see this weird side effect sort of went away. I mean, that's a good sign to me. Now, again, there's some latency between when we're really ready and that thing happens. So I could run this 100 times and it might be okay, and 101, that might end up saying 2.
Depending on that latency.
Okay? Depending on how the scheduler decides to do something that day.
Yeah.
But we could see here, waiting on read, message read, client message hello.
Server send,
got it. Waiting on receive, that. And these logs are coming out of here, right? So they're coming out of calling stop, which is really what I wanted to look at there. Here, right? These are our handlers here. So waiting on the connection was in there. We're waiting on a read, message read. That's our server side code.
Yep.
The client sent hello.
Yep. Server
sends back, I got it. Now we're waiting on another receive. And the client says, I got it. And then I establish a second connection. So here you can see that's 52561. It's 52565. And we go through the whole thing. Now, this is our logger, right? Where we said we were waiting, join trigger, new connection, and then we're ready to sort of read, right?
Yeah.
Now, here's again, new connection. We're ready. We're good with that. But let's look at the shutdown here, because now we've got dropped connection, connection drop, drop connection, drop, shut. Oh, so that's clean. I think this last change just cleaned everything up. This is what we expect to see, right?
Yeah.
Now, if we looked at our server code, right, we're seeing dropped trigger, that, but all that is because we called stop. So once we called stop, we shut down the listener, sort of everything starts to go down. So I love everything I'm seeing right now, right?
Yeah.
So we fixed the sort of logic bug that I introduced when we went ahead and sort of cleaned this up. But now what would happen is if we, in a real world scenario, and I would have to do this in the 90s when we had access to physical machines. We'd build servers like this, and we'd go to the back of the machine and pull the Ethernet cable out. And make sure that our server, within a reasonable amount of time,
shut down.
Not shut down there, but discovered
that. Oh yeah.
If I pulled the Ethernet cable out, that should fail.
Yeah.
Right? Now, in that case, we're going to be in this really bad. Well, it wouldn't be here. We'd come back up here. We'd be in this loop here. Now, that to me is bad, right? Because at this point, I'm not going to recover from that particular type of Ethernet problem here. Because here now I'm just going to go down.
It's just
So
going to
there would
panic.
have to be more logic here to again, if I start listener, let's take a look at something here. We're calling net TCP, right? So the question that I'm asking myself now is, let's say we're doing this one here. What kind of error, right? It's going to be an op error, some sort of op error. It's going to be a listen error. So my brain says the following. If this was going to be much more production code, and this failed, then ideally, I would argue here that if it failed, we'd want to do a continue. All right, I can just say continue here in that sort of, we're going to burn CPU at that point. But at some point, we might want to be shutting down too, right? So,
yeah.
So if you look at this, the first thing in the loop might be, hey, are we being asked to shut down? And if we are, sort of break, right? If not, listen. If that fails, there's a continue there. Now, you can't just say continue. Ideally, if we wanted to really keep it simple, I could say, we're going to wait a full second. Now, what's bad about doing a time.sleep is if we asked for the service to shut down and we're in the sleep, we're not going to be able to do that for a full second.
Oh, okay.
Right?
We're still going to be having to wait that second.
Yeah, right. And this is where context comes in. And at some point, we could leverage a context instead of a sleep where we can detect the shutdown immediately. Well, dude, that's like 10,000 times better, right?
Yeah.
And there's for sure a way to do that. So I'm just going to put a note here, right, to do sort of use context to control the retry cancel, because that would be much cleaner. It would be fun to implement that anyway. But at least right now, this is what we're going to have to do, right? Because if that fails, I can't be burning CPU. Give it a second and then try it again.
Got it.
And then if we're being asked to shut down, and then we can sort of shut down. All right. And again, a good way to test this back in the day would have been to
pull out that
the network. Now, on my local machine, I'm hosting the show, so I can't go into my network right now and turn it all off, right? But maybe after the show, we can come back in here. I could turn my network off to a point where there's no way that where this call wouldn't fail.
Mm-hmm.
I mean, we can even simulate the failure here, couldn't we?
Yeah.
Right? I could simulate a failure here, right? I could just say return nil func.error f forced error, right? Now, when I do that, though, I'm going to do a listener.close here, okay? So, look, let's say I did this just for a minute. I'm going to make sure this fails. So it's I'm forcing the error, even though it worked. In fact, I don't even know why I'm even getting that far with it. Like at this point, just do this.
Yep.
Right? Like, whatever. Wait a second. Let me put all this code back the way it was. Just do it cleaner. All right. So why not just do this, right? For now. So, okay. So I'm going to force the error on the start. What does that mean? That this is we're going to see the error. We're going to wait a second. We're going to continue. We're going to try again. Mm-hmm. And then if we go back and look at our main code here, the start would have tried to run. We're trying to create these connections, right? At some point, that's going to fail. Okay, we will not have been able to do it. Mm-hmm. We're going to eventually call close, and what we want to see is the server shut down cleanly.
Okay.
We need to make sure that, that that we see in the logs this. We need to see this in the logs.
Got it.
That it shut down sort of cleanly. Now, again, since things are not... Oh, we do have the stop here. We haven't looked at how stop works yet.
Okay.
But I'm assuming stop is working with this wait group. So let's see what happens here, right? Let's see what happens here. And just to sort of make it happen even faster, let's do 200 times the millisecond. So let's just see. Okay, so it's easy to get happy path working.
Yeah.
This is what separates the IT developer from the production engineer.
From a product. Yeah.
This here, right? So look what happened here. We forced the error, it couldn't connect. Fine, it finally gave up. Then though this said client sending hello, so our little main program is messed up, but whatever. Okay. We called stop. And in Go main one, I don't think this is a server issue. I think this is a client issue.
Okay.
Because right. So this is we should never have sent hello here, right?
Yeah, it shouldn't have.
We shouldn't have done that. We should have identified that if con equals nil, that, just for a little hack program, right? So that's fair.
And
now I don't think it's staying alive long enough for us to get the logging.
Okay.
Right? So if I say this right now, it's just not staying alive long enough for us to see the logging. Because the Go routine's getting... Okay, so I think we have a bug here.
Okay.
I would still expect on stop, and maybe we didn't need this. I think we have a bug here. See, when we call stop, okay, all this is sort of happening. We're supposed to also be waiting for the done call, right? We're going to have to look at this code next.
Okay.
Well, I don't call done until I've done the log. And I'm not seeing
that log.
I'm not seeing it, right? I'm just not seeing it.
No.
And so we do see forced error, right? Am I seeing this log though? Yeah, that's the forced error because that's what we're returning, right? So we see forced error. We see it trying to start again. I forced the error. That's fine. It was staying in that loop. Then we had this is concurrency row, is nightmare.
Yeah.
Now try a connection. Then we were just calling stop. And I wanted to see this log. But we didn't see the log. So what does that tell me here? This continue came back here. Okay? Came back here, right? When we call stop, we're supposed to be setting the shutdown to 1. I mean, that's happening here. Again, I want to clean this code up.
Yeah.
But it's supposed to be happening here. So what I'm going to do, just to leverage this too, right? Checking shutdown flag. I could do this in a really insecure way if I want. Is this in a format? Okay. This is like bad because now there's a data race there technically, but it's okay for what I'm trying to do right now. I just want to see that getting called, right? So checking shutdown flag, right? Calling stop.
Okay.
At some point we should have seen, so I don't know if this is a problem with the client code, but ideally
it should have gone to 1, right?
Well, when I called stop, that's not supposed to return. Let's just take a look at stop again. It's not supposed to return until the wait group
Until we.
is set to, okay? So it basically blocks here
Yeah.
until that's done. And then the idea is that the only way that's done is here. So then we should see sort of this shutdown cleanly, which I'm not seeing again, right? I am seeing checking shutdown flag, checking shutdown flag. I feel like this go routine is being, it's really weird to me. My brain makes this feel like the go routine is being just completely terminated here. So what we might have to do is this. Again, if I do it with the logs, I think it'll be cleaner instead of fumps right now. Starting, stop, right? Starting, stop, defer, stop, complete, right? At least I can see that, which maybe we needed in the logs anyway, but what were the different types we had? Where was that stuff anyway? We had accept, join, read, remove, event. I don't even know what groom meant. We might have to add another.
I think groom was that. What I was thinking drop was. Groom was the one where it was, if it was inactive, it would drop the connection.
Yeah, I don't even know if we're using groom. All right.
That's what I was getting confused with there.
I don't see where this is red here. Oh.
There.
Oh yeah, we are using it there. All right. What's interesting to me is I got accept, join, read. So let's add an event stop, right? All right, event stop, right? Because I'm probably going to leave this in here at some level. So I'm going to do that, right?
Okay.
And then what's interesting here is if any of this, again, this logic needs to be fixed. But let's fix the stop while I'm here, because I think there may be bugs in stop for a second.
Okay.
Okay. So is the listener, so we have this already, this little function, right?
Yep.
Okay. So has it already been stopped? Is this no? We don't need to call that twice. Okay. Now, we're going to mark this thing as shutting down. Okay. Now, this is interesting here, because in this case, we want to call close, right?
Mm-hmm.
Now, we kind of already have a little function we wrote that calls close. It's
The
this.
reset.
So I think what we can do is just call t.reset, right? And it doesn't have to do anything else. So that's going to call close.
So it set shutting down to 1, or the flag to 1.
We set the flag, hey, we're about to shut down.
Yeah.
We call that.
That
then
closes.
Then I made a copy of all the connections. I don't know why I make a copy. We need to do this since we have a lock, since we have to lock the map to read it. Oh, because when we start dropping, it has to access the map to do lookups and stuff. So we can't lock it. Like there's, now I'm kind of curious what happens here. Nice, right? Like this is some new ghost stuff here. So Now, you know me with this sort of lock, unlock stuff at the client level. Plus, we have this whole client package, right? This is a client.
Mm-hmm.
I'm looking to see if, oh, I'm just making my own local copy of t.clients, which is a map that we maintain here with the client connections. But we also have the mutex around it, right? So what does this sort of tell you at this point?
Okay.
What if we did this? I don't know what the return is just yet, but I can return this, right? Now I can do this. Now, honestly, again, we should have, this should be a read-write mutex, right?
Instead of the
regular mutex, because I'm about to just do a read.
Yeah.
Why am I, again, I think it's, we don't have a lot of concurrency going on there, but this should be a read lock.
Mm-hmm.
Then we should defer the unlock. Then we can just do this. Sorry, bro, my fingers are not working. Oh, somehow that got, you know, I love Copilot, but it sometimes doesn't make my life better. Okay.
Yeah.
So if I put this in a little function, okay, I'm going to start doing this for a second. Start moving these things down, all these little functions.
No, unexported.
Yeah, I like to sort of put all the unexported stuff. Let's put it here for now. I don't even know what's down there with the stats, which I think we could get rid of too, just to keep this code a little simple. Because I was keeping stats on reads and writes, and then again, I mean, it's okay. All right, so look, what did I just build? I just added a function called copy clients, right? That
Yep.
did that, returned our own copy. So, yeah. So if we go back to our stop here, clients, t.copy clients.
It didn't, yeah.
I know, dude. Sometimes it feels like it's there and it's not, right?
And the T for clients.
No, I want a local variable for this. It's complaining it's not used yet.
No, I was saying like clients, like the T. Or
oh, I misspelled it. Yeah, thanks, bro. Okay, so started completed. This has already been stopped. We flag it, we reset it, we copy the clients. We now range over all the clients that are in our list, dropping them, whatever drop does. We haven't looked at that code yet. And then we wait for that other thing to have said that it's done. Right?
Okay.
We don't want to leave until we've seen this happen. That's the WG accept, right? Now, I hate the name of that because it's really the wait group for start, isn't it?
Yeah.
We're going to call it the start G, right? That's the wait group for the start go routine.
Okay.
You can see almost why I did a few things like when you first saw this,
like
right?
separated.
Because they were like sort of things that sort of went together, right?
Yeah.
I just hate when it doesn't sort of line up. Like I have a harder time sort of reading that. So, but you can see the grouping of some things there. And even some of this stuff could be almost put in its own package and API at some level, but that's overkill right now. So let's go back to stop. So at this point, the listener is completely done. Like this is preventing us from accepting any more connections. And remember, every time we accept something, if we're being told to shut down, so that call to shut down is interesting because that's what should be triggering. Well, it wouldn't trigger it until this returned, right? This go routine is blocked here.
Mm-hmm.
So we're setting the shutdown flag, and then this reset should cause this to fail immediately. Then we should see that if the shutdown, right, it's not 0. Now,
so then it would call it.
We've already reset. That's no big deal.
Okay.
But now it should break. And when it breaks out of the 4, it should come into this defer because that should kill the go routine, right?
When it breaks on this break, or you're saying that break?
This break breaks us out of this.
It breaks us out of that. Okay.
Yeah. We're going to add some more logging to triple check that. Now, at that point, we're trying to do a very clean shutdown. We're just dropping all those client connections. Bah, 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 right?
After we've already copied.
Yeah, we get a copy of it because I'm sure drop is manipulating that map in some way.
Okay.
And then we wait for that start go routine to have been completely finished. And that's what's killing me is that I'm not seeing this in here, right? So that's what's killing me, right? So you could see that stop started and completed, which is very cool. We could see from the client side it couldn't connect. But even though I see stopped, started, and completed here, which is great, right? And the only way we got here is if this was no longer, other than the fact that when we call stop, there was an error, which I'm not logging, right? So what if I do this?
Copilot giving you the else.
I know,
back Copilot.
I know, back Copilot. Just to triple check that when we call that, there's no...
TCP has already been
okay,
stopped.
so this is why we're not seeing the log because this anytime you don't log an error, it's your, it's your problem, right? So this thinks it's already been stopped. Now, what's interesting is because we haven't been able to establish a socket, we haven't been able to establish thing, it is already stopped, isn't it? Like there is sort of nothing else to do because, okay, so
because
this is,
it never even had a connection to begin with.
Yeah, we're sort of in this loop, right? And that's the problem, is that we're in this loop now. So again, you see how logic is changing? So even though now, so this is the problem, right? Even if it's nil, this doesn't matter to me anymore. I don't care if you call shutdown twice. I shouldn't care, right? Just we're gonna just make sure that it's set. We're gonna reset. If there are any clients, we're gonna do this, and then we're gonna wait. So this whole problem was because, again, now that I changed the logic, the existing logic doesn't work anymore. Now what do you see?
Okay, yeah, now we're seeing what we need to. The shutdown flag going to 1, that log, yeah.
Now we're seeing it, right? Now we're seeing it.
Oh, okay, and it was because we were checking if it was nil, if the listener was already nil.
Which of course it is, because we've never been able to establish a connection. And now we're just killing this go routine. But if I don't go through this step and look for this stuff, like we don't know. So one thing I want to do in our little hack program is sort of any logging that we do in here, I'm going to add 1, 2, 3 this. This is going to tell me that this is coming out of our hack program, right? Hack program, hack program, hack program, as opposed to an event coming out of our server code. So this is our hack program. Okay. No, because my brain isn't able to distinguish right now. Oh, that's all I care about there, right? And the event is what I care about here. So now if I run it, right, I care about this. So we saw that we caused this. We never got a listener going. Then we called stop. So we see stop info started, stop info completed, and then we see our start go routine, our accept, right, error, and it's really a shutdown more than an error, right? In fact, because now we have the info from a logging perspective, instead of this being type error, this should be type info, right? Should be type info. Okay.
And I saw a blank space. What is
that's because it could be the IP address, which we don't have one for that, right?
Okay.
So now do you see now that if the network is failing, it's okay. We're going to keep sort of trying, right?
Yeah.
And we could even simulate that if I wanted to. I want to move on here. But I could do the forced error for a few seconds and then let it actually work. And you would see that it was fine.
And it would recover itself.
Now it's recovering itself. So if I pull the network cable out and it comes back in now, no big deal. It will sit in the loop. Now, again, I'm forcing which you really don't want to do, right? The time dot sleep right now. But we'll come back and sort of fix that. All right. So now if I run this, this is a beautiful thing now, right? And we have the completed, and we have the shutdown, and we've got the connections dropping.
Got it. Okay. And we're just logging that twice.
Well, there's two different things. There's a trigger that we know that the connection dropped, and then we're saying that we've sort of done it. We can maybe improve that logging a little bit.
Got it. Okay.
Okay. So this is now getting really solid because it's easy to accept the connection. It's how do I identify that the network's not working? And when I do, what do I do? And where do I do that? There's a little more work we could do that. But this is where it's hard sometimes to trigger the temporary error versus the non-temporary error. And I always say I don't want to use mocks to do things, but this is where sometimes you have no choice but to find ways to mock these nasty things that should never happen in production. But if they happen to happen in production,
it's
right now we have to be able to deal with it. Exactly. Okay, so this is pretty good right now. In fact, I might just save this work from a commit perspective. So we have sort of start, stop working, right? And I think right now it's working pretty well. Again, even though we broke the logic because we're trying to clean up some of the mutex stuff here. So one could even argue like this logic here with the shutdown flag, right?
Mm-hmm.
We've got load and we have set on shutdown flags, right? So let me just take this again for a second. Like seeing that raw stuff is always going to cause you pain at some point, and it hurts everybody, right? So so we could just have a shutdown that says bool. Let me just take the code that I just stole here for that. So I can read that, right? And essentially, maybe we just put that in a V variable for a second. And then you read that, and then we say return V equals 0. Actually, not equals 0 for shutdown, right?
Yeah.
Nice. Now we've got we'll call it
what's the purpose of using like the atomic dot load?
The atomic is the fastest synchronization mechanism you have because it's at the hardware level. It's at the CPU level.
Oh, okay.
So if you have to do this sort of flag stuff,
Mm-hmm.
you want to use basically an int32, which is the smallest thing that we can use here,
Mm-hmm.
because now at the hardware level, it's gonna do the synchronization.
Got it.
So that
Okay.
wait group package, if you look at it, it's using all atomics. You don't want to use mutexes here, because now you're spending a lot of CPU cycles locking a line of code, when all we need to do is look at.
Got it. So it's like it's an efficiency.
It's the most efficient sort of way to do synchronization, and it's as fastest way you can do it. So for these types of flags, you don't want to use Booleans. For these atomic, now I could use an atomic variable here, which I always forget exists. So look, the atomic package has actually it has a bool. How cool is that? Okay, I always forget about these variables. So let's say we were going to use this for a second, right? See, now it had, let's see something here. I've never played with them, but there's the load.
Mm-hmm.
So look, if we did that, if we use the atomic variable, I would say then we don't need that function.
Because now it's replaced by just that.
Right? Load's going to return a true or false. So if we're shutting down, how clean is that, right?
Yeah.
This was if we're shutting down, do that. And now, in this case, we would do a store 1. Now, it wants, store shutting down true, right. I always forget about the atomic variables. But how much cleaner is that now? Because I don't have to write an abstraction layer around it.
It's a lot more clear.
At least it's on one line of code, right?
Yeah.
And seeing store and load makes you feel a little bit more like it's atomic, right? So that's kind of cool, you know?
And they gave you that bool that already kind of like
they give you these variables. I always forget because for like 20-something years, I didn't have these sort of things. I just had the API calls. So I sort of always use them. So if we see another place where we can switch to the atomic variables, we can sort of do that, right? And you can see it's all lower level sort of atomic instructions that they're calling, but they know how to do it better than me. So how nice is that? Let's just double check we didn't break anything. Okay, it all works, right? Exactly the same. But now at least I don't have to write another set of functions to abstract these sort of things. I can just use the atomic variable. Super nice. So now stop looks pretty good, right? Who cares if it's already true? We reset it. We wait. That's good. Okay. Now drop will close a socket connection. Where are we calling drop, by the way? So we're not using it. It's something that we've exposed to allow an application to be able to decide they want to drop a socket connection, right?
Okay.
Sort of how we've done it. It looks like we're using concurrency here, which...
And where is this?
That's going to be under client.
Okay.
So maybe we can look at client for a second. The idea of client was that it manages a single socket connection.
Okay.
All right. In fact, this is a pointer back to the TCP API. This is the socket connection. That's its IP address. If it's IP6, the reader and writer we're using to communicate with, you got a wait group there, and then some stats. Notice this is all unexported, right?
Yeah.
So we're getting the time, we're getting the remote address from the connection. This is where we call those handler functions the bind one.
Okay.
So we're asking the client, right here. We're asking the client to decide how it wants to handle reads and writes. We bind into that.
Got it.
We construct a client. We check to see if this is IP6. And then we launch a Go routine that will handle the read. Okay. Then on the drop, I think this comment is useless. We close the connection. We wait for this go routine to finish, and then we log that we dropped it. Then here, we log that we're ready. We've been seeing that here, right? Read ready. So maybe this is better to say client read G started, right? Client read go routine started, right? And we then come in here and we essentially block on the read call. That's the read that we implemented. So in this case, that's this right here, right? Where we block on this read string call. Okay, so the interface is allowing the user to decide how they want to handle reads and writes, buffed or lower level. We have some stats, which is fine. If there was an error, we check to see if it's temporary again.
Yep.
If it's an IEOF, that means they must have closed it on their side. So if it's temporary,
we break.
Oh, if it's not temporary, that sounds better.
Oh, okay.
Then we're done. We call close here. We're done, like the connection's no longer valid.
Yeah.
If it's an EOF, we're done. If not, then we just come back and start reading again.
Okay.
If everything else there is good, we construct this request object, right? Mm-hmm. And then we call process, which for our purposes was this. And it just stays in that sort of loop, right? And that's what you have to do. And then once this loop is over, like we did the break close, right? We get to a break close here. The loop is over. Eventually, it needs to end in some form. We remove the connection through this API that we wrote. We then call done, and we log. Now, from my perspective, I think it's better to log before the call to done because the done is causing things to wait. Okay. So we should have a better chance of getting the
log there. Yeah.
The log there, right? And even one could argue that we could just even do it here and it'll be fine, right? So we're dropping, let's say dropping connection or something, right? Now, I don't know why I called this a trigger. Like, I come back here and I had this idea that it was a trigger. And that might be because I don't know why I called it a trigger. It's interesting. We don't have to solve that problem now, but it looks like instead of using info, I used sort of trigger. I don't know what I was thinking there. Let me see what happens if I get rid of sort of trigger. I don't know if I was trying to say like this was some sort of event that occurred, but the only other place I do that is here, but just call it info for now, right? Okay, and so this is fairly creating go routines because that go routine socket connection has to be on its own G to handle the read. Okay.
Okay.
Now, there is this idea of a remove. So we're going to get to all of that in a second. I feel like we're mixing some concerns here, but we'll work that out in a minute.
Yeah.
So let's go back to drop for a second. Drop now says we're going to drop this connection from the clients, right?
Yeah.
Now, if we look at this original code, it looks like I'm doing a map lookup for that. And if I don't find it, then I'm sort of out, right? Like it's not in the map. Okay.
If it's not in the map, that means they disconnect. Okay.
Yeah.
Yeah.
No. And then if it is, I call drop. Now I do this. Drop the connection using another G since we are on the socket routine, most likely. Again, the idea here is that if we're on the go routine, that if for some reason this go routine, where is it on the client side? This read is on a go routine. Okay?
Okay.
That read is on a go routine. We haven't seen where that happens just yet. It must be here on join. Let's go to join. Okay. That's the join, which is another set of unexported functions. So maybe I should move these down, right?
Yep.
All right. I almost feel like I want to put these in a separate file, but I don't know what to call that file just yet. So let's look at join for a second. So on join, I have the mutex lock, unlock, validating that this doesn't already exist in the map.
Mm-hmm.
And then I'm adding, there's a call to new client here, which in turn starts the go routine.
Oh, okay. So that's why it had to be.
It's kind of hidden, right?
Okay.
It's kind of hidden because the new client basically launches the read here. Okay, so it's that call that sort of starts the thing. Now let's look at this because it's using the client's MU here, right? And the entire function is essentially in the mutex call. So the first part of my brain says, I think Bill was trying to be clever back in the day. We could do that, okay, for sure. The whole thing can be there.
Okay.
Now, I'm validating if the IP address, which we get out of the connection, already exists. And if it does, then we say this is already connected and we close that new one.
New connection. Okay.
Now, I don't need this anymore, right? So we just do the return. And then we add the client to the map. I think this is an obvious thing that we're doing based on this IP address, which has that colon and that little number associated with it.
Yeah.
Now, we keep getting confused because the new client starts the read, right?
Yeah.
So maybe instead of new client, call it start. I mean, it's a new client.
Yeah. I mean,
the other option is this. Like construct the new client and then do in other words, if I come back here now, I do something like
okay, I see. And kind of separate it a little bit.
but this is going to appear like it's a blocking call is the other big problem here, right? So but I don't want to do the lower level stuff sort of out here either, right? You know, I just think what's happening is I'm getting confused, right? Actually, this doesn't even have to be. Maybe instead of async read, this is start. Start feels better to me. I like the idea of the construction and then starting something.
Okay.
I've always sort of liked that idea.
Rather than doing it together.
Together. Just because sometimes you have a bunch of construction that has to happen
Yeah.
where there's interactions, and then you want to start sort of the thing,
okay.
right?
Yeah.
And so even though starting is just about adding one to the wait group and doing that,
and that go routine.
Yeah, there's not much more going on there, right? Because it's now doing this read here. And then the drop is calling close and waiting for that wait group to come back, which is fine. And we went through this code, so I'm fine with that. Yeah.
And there, okay. In that column.
I mean, because the other option is to do this. I just don't know which one is sort of better, because if I do it this, then I'm asking it to handle all the concurrency, and that's not what I want. We're doing the concurrency here.
Mm-hmm.
So instead of drop, I want to rename this to stop. Oops. All right. All right. So let's keep this. The join is basically going to construct a new client and start. Like, I was missing that. All I saw was what? New. I didn't see like, when does it get started? Now I know when it gets started.
The starting was actually hidden. Yeah. This way it's a little more clear.
I don't need all those. I think these comments added some value. Like, that was important. I think that's important. Well, I'm going to leave it. And then these messages are important. I'm going to leave it. Okay. So that's the join. It's essentially... Now, I hate when we're going to do some logging, and then this is going to keep the lock a little longer. But we're not in this like massive high throughput sort of situation. So I know at least when I have the lock and I do these things, it will be synchronized with everything else that we're doing.
Okay.
As opposed to I saw it and then we block and then a bunch of stuff happens and then we finally get to it. That could be really hard to like decipher in the logs.
Yeah. So this way it takes a little bit longer.
We'll sit in the lock a little bit longer, but we're not doing high throughput. Sort of, if we were writing a DNS server, that would be like death. Like, you can't do that. Okay. Yeah. Okay. So I like the join here, right? And that comes back now to this. Right? Add this new connection map and start the client go routine. Let's just put that there because it wasn't obvious, right?
Yeah.
And maybe even though this is a join call, maybe this can be called... Why does that happen to me, bro, all the time? Hit the wrong button. Rename. Start. Like, doesn't that... I think that's going to feel better. Right?
Start. Start the client, go routine. Yeah.
Yeah, start this connection, right?
Mm-hmm.
Yeah, let's try that. So, that's that. Then you have this... basically drop will close the connection. But why am I calling it drop when I really should call it
close?
I think. Right?
Close will close the socket tonight. Yeah, I mean.
Now, let's get back to this here. And again, we have to do this call on another go routine because they might be making the call on this go routine.
Okay.
And now you've basically deadlocked.
Oh, okay, so you have to move it to a separate one.
Go routine. So these two other, the problem is that you're controlling the go routine. There's
Mhm.
two camps here. Let the caller manage the concurrency or you do it. We're going to do it. I think it's easier.
Got
But
it.
if somebody is sort of, this is a function we've asked them to implement. What if they're trying to call close and they're here? What's going to happen is this will never get to return because the other code is also trying to get into
Got it. And
this is
they'll conflict.
heavy duty things, right?
Yeah.
So because we know that if you call stop, we're going to do this, we have to wait. But if you're going to wait, you're going to wait forever
Because it's never going to reach where it needs to reach.
because that's blocking this call here, and it's never going to. Where is the done? Whoa. Where is there a done? See, this is
Done.
bad here, right? We should move this to a defer. Oh, yeah, we should move this to a defer. That's why I just got confused. So when the read function closes, it shouldn't be down there, right? It should be here where we say we're dropping the connection, we remove it. Now I see the add, wait, and done together.
Oh, okay, yeah.
Like I didn't see it. Like where is it? Again, this code was 8 years old and Bill was not doing things the best way. But this now feels a little bit better, right?
It's more readable.
We know it. We know it's going to get called done. So imagine this go routine on the read call is calling stop. And now it blocks on wait. So now this is waiting for this thing to end so it can call done. Never going to happen.
Yeah.
And so this is why in these sort of cases, we've got to call stop on a separate go routine. So when stop is called, it can close the connection and wait and allow this go routine now to
finish. Okay.
to do what it has to do.
So it'll wait for that go routine to finish and then it'll do it.
Because it's on a separate one. If it's the same one, you've deadlocked.
Okay.
You don't want to be looking for that stuff.
Got it.
And because we have the wait groups, everything is still sort of clean. Close returns, which is sort of a bummer. This is the only bad part, right? You said close, it returns without you having a full knowledge if this all happened yet. So the question is, do I need a guarantee to know that this has happened? Right? And if the answer is no, which is what I'm saying here, then just call close and move on, and you can assume it's going to happen. Everything's okay. If we needed a guarantee, then we couldn't just do a blind go there. We'd have to wait to know that it finished. We need another mechanic after this. It said, stop, wait.
Okay, because you need that guarantee.
If we needed the guarantee, but I don't think we need the guarantee here. This is more like,
yeah, you're closing anyway, kind of.
Yeah, thing. We're closing the. Now this close really should be close. Right, we're closing a client. And really, what we're doing is closing a client.
Close the socket connect.
Yeah, we're closing the client connection, right? I don't know. That's kind of what we're doing, right? Even though we called it stop sort of here. Maybe this should be called close, right? Because that's what we're doing. And this should be called, right? Client read G stopped. And who cares about the word read? So that's the client G stopped, right? And then here we're closing, like the connection's closed, right? That's what we did here. This is the start. And then when we come here, this is really close the client connection. but maybe we can get away with just close client. I want to specify that it's specific to the client here, as opposed to the TCP server.
Yeah. Okay.
Right? And now I come back to this mutex. I keep coming back to it. The whole point of us mutexing in here is because we're looking for the client. We need the client, right?
Yeah.
Okay. From our map. So let's go back to, I'm going to fix all this too. Let's go back to our things here. So that was copy client. Start takes a new connection and adds it to the manager. Should this be called like start new client? I'm wondering why this function is exported. Oh, because it gives the caller the ability to shut down this particular client. Yeah,
Okay.
I keep forgetting that. Even though we're not using the functionality, I've needed it in the past.
Oh, okay. So we're not using it right now.
We're not
but
using
it's
it,
there.
but it's an exported API for that.
Okay.
So this is everything here was related. So these three were related to the listener, right?
Mm-hmm.
This set is related to client stuff, right? And so we had copy the set of clients, start a new client, remove deletes a connection from the manager. But it also closes it, doesn't it?
Why is like this remove? Why is this not like a read write lock and it's just like a normal lock?
I don't know. We gotta because of the delete. It's doing a mutation to the map, so that has to be a write lock.
A write lock. Okay.
Now close. So we have this idea of start a new client and then close the client. Yeah. And closes it. So this is like removes a connection from the manager. It also calls close. No, we're going to clean this code up too. Hold on. Just, I didn't want to lose this for a second.
Mm-hmm.
So I would make the same argument here. We should be able to do this. All right. Let's take a look at the rest of this code though. We're validating that it hasn't been removed already. And if it has, it's that same sort of logic already connected, already removed, right? It's not there. Mm-hmm. If it's not there, fine. Then we're going to delete it from the map. I think that's an obvious thing here. And then we're closing it just because it doesn't hurt us to call close. Okay. So the idea is start, adds it to the map, close, removes it from our map. And then this logic here, where did we, oh, this is where we're trying to get a client back, right? Where was that logic again? That's not in send. It's in close client. So close client will close the socket connection. I feel like we just had some redundancy here, didn't it?
Yes.
Oh, the close part that we just, all right, hold on. Dude, this sucks. Close client is being called here because that's where the map is. Right. Okay. Close client removes it from the map. I'm just going to copy this for a second because I want to see what we're doing up here. This is an external API. This is
Yeah.
letting the caller, the user of the system,
Okay.
do this, right?
And this is
code that we
internal.
had internal for the
Yeah.
client to be able to remove it from the list because it's saying, hey, we've sort of done this, right?
But it seems.
Yeah, it's like getting it out of the list as opposed to, but what happens is if you close the client, then this gets called automagically when everything sort of shuts down. So ideally, what this is trying to do is just sort of, this will get called through that. Another reason why you see how this is going to end up being in a client mutex call. That's going to end up being in a client mutex call too. Like this is, I hate event-driven software. This is getting into event-driven stuff. So this is for you to decide. I just want to close this thing early. So from this, we're trying to find this. That's essentially what we're trying to do. It's a lookup just so we can call close on it. So for me, what we're really looking to have here is like a find client. Given that, again, this should be a read lock, right? Because this is a find. Okay.
And a write lock would be like adding to the map, let's say, or removing from the map, like adding or removing.
It's either you're reading or you're writing. If you're reading, use read locks. If you're writing, you have to use write locks.
Yeah. Okay.
That's essentially what the deal is going to be. So let's see something here.
Yeah. Okay. So read is not altering anything. It's just looking.
So I'm looking to see if this, I need to bring back this client, right? So I could do this, I think. And instead of okay, I usually like using the word exists, right? If it exists, doesn't exist, exists. You see how exists is better than okay?
Yeah.
Yeah.
I think that makes it a little clearer.
So if it doesn't exist, nil, else return C nil. So this little function now called find client can do the lookup for us in the map. Like I almost want, you see how I created a client sort of API?
Yeah.
It would be nicer to have a clients around its own API as opposed to integrating it all in sort of TCP, because you can see how disjointed some of this feels. I would almost want to at some point take all this API,
move it to its own
its own little thing, and maybe we'll do that once we know this is working. It'll be an easier sort of refactor. So now we're back to the closed client, right? So essentially here, I'm just going to say error t.find client. I don't know, just leave me alone for a second. Just kind of what that was, right?
Because essentially we're doing that same lookup more than once.
Yeah, but so in this case, easier. I just need to find the client. Yeah. And then if I found it, then we'll call g.close on it.
Yeah.
And now the same thing happens here with send, right? I want to send this response. So in this case, we want to find it. That takes all this away, right?
Yep.
And then we can send the response.
But that goes still.
That's because it wanted that.
Okay.
Nice, right?
Yeah, much
It's just
much
cleaner.
better.
Find it, do your thing, right?
You know, it's doing kind of the similar.
Yeah.
The workflow's a little easier.
Let's just double check we didn't break anything at this point. I haven't run this in a while. Okay, good. Now, send all will deliver the responses back to all connected clients. So we already wrote a function called copy clients, didn't we? That's copy clients. Now that gave us it in a map, but I don't think that's a big deal because I could still range over the map. It wouldn't be in the same order every time, but let me see here. So now we do the write. If there's an error, we put it back in here, and then we can return any errors that we had trying to send it. So that would be the same sort of thing here, right? We just make a copy
and the order doesn't matter because it's just sending it to
nah,
everybody.
the order doesn't matter. And I mean, even if you had 1,000, it may be inefficient in the case where you have 10,000 connections because we're making copies before we do that. But you would be in the read lock a lot longer otherwise. So I think the memory is fine for that. Now this is trying to tell us how many connections there are by doing a read on t.clients. This is, I guess, again, we're exposing it. But I think if we're going to do this, now none of these APIs have dealt with mutexes directly, right?
What do you mean directly?
If you look at the exported API, you no longer see atomic instructions, though you do see the use of the atomic variable here.
Mm-hmm.
Well, we've hidden all of the synchronization stuff now essentially into unexported functions.
Okay.
You know?
Yeah.
But the efficiency of this, which should be an rlock, defer runlock, return that. Like, it doesn't make sense to make a copy to then tell me how many clients we have, right?
Yeah, just tell me how many clients we have.
Now look, that's the complete exported API, right? It's cleaned up. I do have this stats thing. So let's do this for a minute. New file, stats.go, package TCP. Let's at least move this out for a minute.
Yeah, that has.
Even it's still part of the. It's not using stats though, is it? No. That's weird. Do we have this twice? Look, we have this idea of connections.
And then clients.
Shit, they have the API there twice, don't we? That's funny, bro. That is hilarious, right? Yeah. I think we'll call it this instead. So I had this twice. How bad is that? And then groom drops connections that are not active for a specified duration. So this already tells me that we want to use our t.copy clients, right? Gets rid of all that. And we've got our clients here. Again, I'm not even going to go down this path right now, but at least clean that up, right? And then this is part of your larger exported API. That's fine. And now we have this unexported API where you have these calls that are specific to the listener and these calls that are specific to managing the client. Now, if I look at the stat stuff, which is the last thing, this is just a data model where we call client stats. And again, clients equals t dot copy clients, right?
Yep.
All this goes away. And then I'm essentially iterating. Why do you not like I? Oh, because this is now a map. Okay, but that's not a big deal. We know the length, right? So we'll just do it this way. If we do it like this, there'll be efficiency. So stats equals append stats. Stat. No, I don't need this. So essentially what I'm doing is I'm going to set the capacity to the length with no actual length. So append will just start filling in the elements from 0. There will be no extra little memory allocations. And this is because we're ranging over a map. So this is the efficient way of sort of doing the indexing.
Because we know the length.
I know the length, but I don't have an index. So we set the backing array to a certain capacity, but we say that there's nothing in it.
Oh, okay.
So then we start appending at index 0, but the memory's already there. 2, memory's already there. 3, memory's already there.
It already allocated it.
It already allocated it. We're just using append to say index 0, index 1, index 2.
Got it. Okay.
So I'm okay with the TCP API being here, right? We've isolated that. What would be interesting for me on this, right? This is a client. What if I added clients.go for a second? Okay. So all of these APIs are very specific to, let me put it here for a second. They're all very specific to these two things here. This, right?
Yeah.
These two things. So we could still haven't learned how to do that very well. Could do something like this, right? Function new clients, where it returns that.
Oh, clients is misspelled there.
All right. So where we construct the map like this, right?
Okay.
Then the idea in here, and we're not really done yet, but this becomes
new clients.
Oh, it becomes clients. I can get rid of this. Now, ideally also, this probably doesn't need to be exported because it's all here locally for now. Okay?
Okay.
Now, we'll fix all this in a second. But if we encapsulate all the client stuff here, this would be an API. I got to get rid of T, obviously, but I think it's self-evident what this is doing. So what we would say now is, now we don't have a log here. So on the new, then what we can do is ask for the log, right? We have a logger. So I could choose to say I need this and I want a logger of that type logger, right?
Okay.
And we can ask for that logger of type logger.
And we have that because it's encapsulated?
We have it because we create that at the beginning of the TCP, and that type is already defined somewhere.
Okay.
I thought it was defined under models. It must be defined at the top here. But let's just keep going for a second. What's wrong with this? T dot copy. Oh, we moved it. We haven't. We're going to fix that in a second. All right. So now if we isolate this map into its own sort of API, this is what would happen now, right? So you've got the copy clients there. I'm just doing it slowly. I want to see. Now I have to call this log. Log. Now maybe we're using the wrong function at that point because, oh yeah, string. So maybe we use the same exact this signature here, which I didn't put into a type because it's an internal thing.
Okay.
But if I do this, which now I'm thinking I want to put it into its own type because it's so long, right?
Yeah.
Like internal logger, right? And I can come here and say this is the internal logger.
Got it.
And that's fine. We got to fix all that. But that's our internal logger. Because at the, where is it? Why can't I? Oh, at the config level, we asked the caller for a logger that looks like this. But our internal logger is using ints, right? So now I say internal logger. Now all those calls are fine. Now, I can't use C without breaking everything. So let's go with a 3-letter receiver. So that's a 3-letter receiver. And do the same thing. Actually, that one's got to stay lowercase c for new client. But that's the client, CLT. CLT. So we're just abstracting away the nastiness, right, of sort of this. A new client actually takes a, okay, that's like this new client call. Needs a TCP. It needed to know its TCP. So that's fine, right? We can do the same thing I did here. Some of this smells, but but we can look at it again when we're done. These things start to happen when you're not breaking these individual things into their own true packages.
When you're mixing, so when you're mixing, like,
you're mixing things kind of in the same package. This is going to happen, which is sort of the smell, right? So now I can't just call this T here because that doesn't really make any sense. In fact, I think it was wrong to call this T here. Let's call it TCP. All right. Yeah, that stuff doesn't exist yet. All right. Okay. So we encapsulate that. We're going to fix that. We're going to fix that. We called this CLT for clients. Okay, all that stays. And this sort of stays, right? Okay, so the only other thing that's red is right around here.
Right there.
There. Okay. So we've kind of encapsulated this client's thing away, which is nice. And even technically, if we put it in its own package with its own namespace, and this is the exported API, it gets even cleaner. But that's okay. Like, now we come back here for a second. Not here. Come back here for a second. So now we got the idea of the clients, right?
Yeah.
So in this case now, this is going to be a new clients, which now I've got a chicken and the egg problem. Damn it. I got a chicken and the egg problem, right? Because this already now smells. I can't create new clients until I have a TCP, and I need the TCP to create the
Okay.
Remember, we've been here.
Yeah.
We've been here before.
Yeah.
And now I want to know why I need TCP. Like, what was it? It was just the one call that we needed it for. Let's take a look.
Well,
because when we
yeah.
call start new client, we wanted to do that. So what we're going to have to do now is this has to be removed from here. In other words, wherever we were using start new client, wherever we were using that, we're going to have to do something here.
Okay. And that's to avoid that chicken and the egg problem.
Yeah. Which now would mean that we wouldn't call this. So if I get rid of this, I get rid of this. This starts to also help you sort of smell. Oh, dude. See, we're mixing some concerns here because if this should just be managing that's okay. That's okay. It shows me that we were mixing some concerns because we were able to. So I'm going to get rid of this for a second. Hold on. Come back up here. Clients. Okay. So I want this gone. Okay. I want this gone. I want this gone. And we're going to call this add new client. Okay. And oh, shit. The problem is to add a new client, we need a client. It's like this code now becomes sort of this instead.
Like,
yeah.
Like it would return.
So I would do the following. We can call new client. Why does client need TCP? That is the bigger question now. Is it all because of logging?
There was a close.
It's all because of logging. No, it's also because it calls this stuff here.
And I saw a close also.
Yeah.
Close client.
Yeah, it needs the TCP. And yeah. Okay. I'm going to put this back. I'm going to put this back, and I'm going to get rid of this for now. And then you're broken because I did some things I shouldn't have done here. Okay. So let's keep client separated the way we have it. I should keep that for now. And then I think because we've got this tighter integration, right, between, we'd have to take another pass at separating some of these concerns here.
Okay.
And at this point, like, this isn't my biggest sort of problem. So I think, let me just make sure it still works. Okay. Because even this would have been a little bit nice, but like this should live on its own. But we're doing more than just adding and removing clients from this list.
Got it. So
right, this entire API that we wrote, right? This is listener stuff. is doing more. This is just reading the map, but this is constructing a new client to put it in the map, and then it's telling it to start.
Yeah, so
right.
It's depending
This
on a lot.
we've put more logic in here than, like, that would have been fine. The close would have been fine. This
So
gets tricky because
it's the start.
It's the start because really, in our case, all we need to do is this add, right?
Mm-hmm.
Like everything else is sort of new. So I wonder then if the start new client stays here, and all we do is add, and all we do is have this add. But we also had to do the lookup here, didn't we?
Yeah.
So it's a couple things going on here. We have to validate if it exists before we create a new one.
Yeah.
And so we could change the logic of this function to say find client,
mm-hmm.
and then if it doesn't exist, do that. But now we've got locks and unlocks going on. But it would be the only way to do it. So we would do a find, then we could do an add. So look, essentially this is copy. Let's just keep it on this API for a second.
Okay.
Okay. So say I was just going to do an add client. Okay. Where I do have a client itself. Add client. So what would an add client look like? We definitely would have a lock and unlock.
Yeah.
And we could for sure check that it already exists, mm-hmm. right? Like this would be your pure add client, but we're in a lock and an unlock already. And the problem is, again, is we haven't, so let's say we had this and now we wanted to write this function for a second.
Mm-hmm.
How would this sort of function change? So one would argue that we would do a t dot find client given a we don't have the connection yet, right? When we do find, we do it on that. Let me see. Yeah, our find is based on a TCP address, mm-hmm. because anytime we've used it, we've had the TCP address. But in our case here, we're handling a connection.
So we don't have the address yet, or we don't have the TCP address yet.
No, I don't think so, unless the connection has it, and I don't remember if that's. Yeah, the connection doesn't have a. Oh, the local address is there. Looks like we use remote address though. Okay, so what if we did this? We'd have to make sure it works. This takes a TCP address. Remote address is a net adder, right? It's not a, it's just it implements the interface, which, by the way, this does as well, but I can't necessarily guarantee that's the concrete value that's stored inside of there, right? So we could do this add client. We're given a client. I have its IP address, but this is getting, let's go back to this. See, you also now have situations where in some cases, this is raw. We're starting with a network connection, right? Mm-hmm. And what happens if I go to this? You see here, we're just working with now this is actually bad code. This code could panic. This code here assumes that all remote addresses are net TCP. If that's not the case, it would panic here.
Okay.
Right? But this is the code that gets us out of the other problem, because even though it's bad, let's go back to, did I get rid of? Oh, I don't know what I'm doing anymore. Okay, hold on. Hold on. Let me just put this here for a second. I had the function before, right? TCP add client.
Okay.
Where we know that we're going to end up with a network connection. Okay?
Okay.
And there's sort of no error here, I don't think. Let's just go back through this again. So this code that I sort of just dropped in here, again, it's bad because if this isn't a TCP address, this code will panic hard.
Okay.
Okay, but with that, I can then call t.find client. And then that's going to give me back a client or an error, right? And if it doesn't find it, let's say this does return an error for a minute. If it doesn't find it, then we can return it's already connected, right? This, oh, but this is supposed to take a client. Sorry, dude. This is assuming we already have a client.
Okay.
So I got this wrong. This is assuming, sorry, that we're not starting with a connection. We're starting with a client. I'm trying to get it so we're not bound anymore.
Yeah.
So then we can move everything. So given a client, I have a con, which has a remote address, which has a TCP. And at that point, if it exists, I'm just trying to figure out if it already exists, right? Like we've created it.
Yeah.
I just want to know if it already exists. But we were essentially doing that at the IP address level. Maybe we don't have to do that here. Maybe we just blindly say, look, that's all we do.
Just add the client there.
Just add it. Let's say that's what we do.
Okay.
So given a client.ip address, we add the client. Let's say that's what this API does.
Okay.
There's nothing more than that. Now, if we come back here for a second, we do t.find the client.
Mm-hmm.
Do we have a client? This goes back to this code here for a second. Okay. So all I have is a network connection. So assuming it's always that concrete type,
Okay.
we do this. Okay. And if C doesn't equal nil,
That means they already exist. Okay. Yeah.
then it already existed, right? just say that.
Okay.
Okay. So now what we get to do is construct a new client and then call add client,
which would be C. Yeah.
See, now what that did is it separates
The add logic from starting.
See, and now I can put all this code into my own client's thing now. Because what start new client does is it just validates, hey, does this thing exist? If not, create a new client. That's your job.
Yeah.
Add it to our thing and
start.
then say start it, right? And then what that does, what time is it?
1.
If I come back here again and I do this again, what it does now is it lets me take this out again. Plus, I need the logger, right? Which I'm going to call this the internal logger again, right?
Yep.
So I can do this again. Now I can deal with you later. Yeah, you're complaining, but it's okay.
I can take those.
Yep. I'll fix them. I'm leaving this one.
Yeah.
And I'm taking these guys.
Yep.
Because they're isolated to just what this is supposed to be dealing with.
Mm-hmm.
And now we can look at this again. So you're doing this, you're doing this, you're doing this. We love that.
Yeah.
Okay. You're doing this. Even if it's in the same package, at least we've sort of separated a little bit.
Mm-hmm.
So you're managing that, you're managing that, you're managing that. We love that for you. When you're closing a client, we love that, we love that, we love that, we love that, we love that. Okay. And then we've got clients here. And you're all good here, right? Okay. So now we've got an API just around this map of clients. Now we can come back here again. Say clients. Now we can do the new, we didn't even create we need a function, new clients, that takes the internal logger and this we don't even have to do. That works in its 0 value state. So what's cool here is now I can say new logger L. And it should have, oh, this needed to be a pointer. Sorry, it's an API, right?
Yeah.
So now we have the new clients here, right? And now we can say t.clients. Now, what's also nice, come back here, is we just call this copy. Let's call this add. It's redundancy in the name, right?
Because we're already in the
close.
client.
Again, I don't think these comments are adding any value to our lives. And this is now find. Nice, right? So clients.copy. Clients.find.
Okay.
Clients.find. Clients.copy. Now, this returns a number of active clients, right?
Mm-hmm.
Well,
That can go there.
technically, you know, we can call this count. And damn it, how many times a day I do that? So this is now count. And now we just come in here and we just do a return for t dot clients dot count. And this is t dot clients dot copy. And this is t dot clients dot find t dot clients dot add. Sweet.
A lot cleaner.
Yeah, because now all that has been sort of encapsulated. Yeah, Mohammed, I know I should be checking for okay. For sure, I need to be checking for okay. I just don't know what to do right now if it's not. So I'm just like ignoring that situation.
Hopefully it's not okay.
But okay. Yeah, you can't put this in production without the check. Now, this again would be clients dot, this was copy. All right. And now you are complaining about this, TCP dot clients dot close. Okay. I wonder if we broke anything. But because you see, a client has access back to its TCP connection, so it can report back to its parent things like, "Hey, I'm heading out of town," right? But it's going to do that through the client's sort of API there. So what's nice about this is we've encapsulated the management of this map, right, through a nice cleaner API. If we have to do anything else with the map,
we know it's there.
We have to do that, right?
Yeah.
I don't even think we need to comment for that. So
the only thing in TCP is the start of it. Starting that new.
Yeah, we create a new sort of clients list, right? Yeah. So now in TCP, to make sure everything still works, we now have a set of clients, right?
Yeah.
Like this still bothers me on the listener that I have the mutex out here, but I don't know how else to sort of handle that just yet, because the listener is part of this thing.
Got it.
Right. Okay. And we have to be able to use it on the, I think it's on the close.
Yeah, on the we
call the reset TCP listener. Now, remember, we've built an API around that too. We've built an API around the listener, right? It's a we have this sort of API around the listener, right? So, like, again, what you could do is the same thing with clients. We can call it listener and just sort of manage this in another sort of type, instead of making it a part of this sort of larger thing. Yeah. Now, the start new client is interesting to me because it's used here. And wait, did we check that we didn't break anything first of all? Oh, dude, completely broke something, right?
Connection reset.
So that's never fun when you break something here. So now we get to debug this thing. Join. Look what it says. Already connected.
Yeah.
So our logic for already connected on the first join broke. So essentially what happened was, my guess is we went to start new client, right?
And it's found.
So this logic is wrong. If C, Oh yeah, it shouldn't have found it. C should not equal. Oh, that's the error. That's the client. Oh, hold on a second. Let's take a look at what find does.
Okay,
Find looks it up. If it doesn't exist, this really should say not found.
yeah.
So if there's an error here, it means that it was not found, right?
Mm-hmm.
And so we're saying if error not equals nil. Oh. Yeah. What are we trying to do here? We're trying to make sure it doesn't already exist.
Yeah.
So this is fuzzy logic. We got to fix this. We're looking for this client. If we get an error, we couldn't find it. Okay.
We're returning the client here, but we're not getting the client.
We're looking for this, and we're looking. Shit. We're looking for this, right?
Yeah.
And we don't want it to be found.
No, we don't.
So if this is the logic, if error is nil, that means it already existed. And then we're bad. We want this to fail. We wanted that to fail. Now it's working.
Okay.
All right. We wanted that to fail because this is sort of a lookup where we don't want to find anything.
Got it. Okay. Yeah. Yeah.
Okay. So like I said, we could do the same thing now sort of with the listener and manage this thing a little bit better, right?
Move listener out the same way.
Right. So come back in here. I'll come back here for a second. Pull this. I don't know what I just did, but pull this out. Put this in here. Come back here. Change this to be, take these two out. Put them in here. Then just say a listener is a listener. Mm-hmm. Okay, and a pointer to a listener.
Pointer because API.
All right, because it's going to be an API. And what's even better is this works in its zero value state. So we can actually, oh no, that's going to be right there. But when we do this here, where did I put it after clients? A listener can be the address of a listener. Like, we don't need a new listener function, which is kind of cool. Right, so now you have your TCP listener. Fine. Let's do this fast here. There. That's going to break, but I don't care. We'll fix it.
Yeah.
Just get lucky every once in a while. Unlucky every once in a while. All right. So then you have this. Then the start listener would be. Oh.
Yeah.
All right. Shoot, what is that code supposed to look like? The type. Where did that start listener come from? Damn it. This came from TCP. So we got to pass this in. Hold on. We need to pass that in.
Oh, okay. And that'll be, okay.
You need to pass that in. So now you got this little listener API, right?
Mm-hmm.
I think now you can just call this reset. call this start, right?
TCP listeners.
I hate this, but let's just call it get for now. Technically, it's, you don't, yeah, you need to, let's just call it get. I hate that name, but let's just start with that for a minute. So now this is going to be listener.get, right? That sucks. I almost want to, I'd love to just call that listener dot. Let's call it TCP listener.
Like init? Or?
I'm gonna just call it what it is. Okay. TCP listener. And now this is going to be t dot listener dot reset, right?
Yep.
T dot listener dot start. Now
that's the one that gets
right, but that's no big deal. We have it here under
T dot.
I don't know why it's not there, but we have the net type and address, right? So I broke something, but it's okay. Oh,
TCP. Yeah.
So now you have that. And then this is listener reset, right? Listener reset. And this is listener reset. Nice. So like this is coming down a little bit now because we've got little APIs that are managing all of the nasty concurrency.
Mm-hmm.
We could, just to be consistent, say function new listener. Funny thing is this all works in its zero value state, so it's a little silly. But just to make this feel better, right?
Okay, yeah, I was gonna ask why
because you didn't need it, but from a code readability, it could be confusing to not have the new sometimes. So now, what's nice is we have the listener reset. We have a listener here. Now, when are we setting the listener though? On start. On start. Wait a second. Let me think about this. Oh, listener start returns the listener that we created.
Yeah.
Right.
Okay.
Yeah. So we're storing the listener. Let's just make sure we didn't break anything else. It's working. That's good.
Nice.
And so now all of that ugly concurrency code, synchronization code, right? It's all hidden behind these sort of APIs now, right? Clients. And we've isolated this to just do what it's supposed to do, which is manage clients, manage the listener.
Yeah.
And then we've got this one interesting function that says start a new client, where it's got to look in the clients list to see if it's there.
That's
then
like
it can
integrated.
construct it. Yeah, it's integrating, right?
Yeah.
Then it's adding it back to the client once it does that. And then it's calling start, right?
It's interesting how we were able to shorten that.
We're lucky that no two people are going to connect with the same address, or there could be some weird side effects here between checking it and then adding it, because you're not in a complete synchronization lock between the find and the add. Sometimes that can bite you in the ass.
Okay.
So sometimes you got to stay in the lock. And sometimes if you're going to do a read and then verify something's not there and do something, you want that entire operation in the same lock. This is sort of a disjointed lock, but no other connections coming in. This is so unique that we're going to get away with it.
Got it.
We're going to get away with it here. But that's why we had the whole thing in a lock to begin with, because if we didn't find it, then let's add it in case somebody else is coming in trying to add the same thing. Never going to happen here.
Yeah.
So we're gonna get a little lucky.
Very cool.
Okay, let's push this code up. because I think sort of a refactor. I think we now have a refactoring of the, oh, shoot. Forgot to,
Oh, the new files.
new files. I got a refactoring now of this. And instead of having all these little separate packages, because we want this all in one package, we went with the idea of these type-based APIs to sort of isolate some of the complexity, like what a client is, a set of clients, the listener stuff, because the way we're using it, we've got to be able to manage that. And that reduces a lot of complexity now out of the logic.
TCP.
Yeah, the core logic, right? Though the original code, we definitely broke some stuff. So I think there's some work you can do here to control the retry and the cancel better. That sleep is really bad. And then to Mohammed's point, which I did know, I just wanted to avoid the, where were we doing the type assertion? I thought we were doing it here. Where's the nasty, nasty type assertion? Let me look this way. TCP. Who is it? Oh yeah, here, client. This stuff right here.
Oh, okay.
Anywhere that we did this, which a lot of it's happening in vendor too. Look at that. You see, they're not even checking either. They're just, it's almost like it's an assumption here, right? Maybe we get away with it. This could blow up if that's not what's in there. But I guess because we're working with TCP and not UDP at any level, we're going to be fine. We're only accepting TCP connections. So I think we end up, if that isn't the case, life would be really bad. So I think we're fine there. Okay, so I would say that this code is now cleaned up and we know how to use it. Agreed?
Yeah.
So I gotta look at my calendar right now, cat main. So we've done at least the communication cleanup. So now when it comes to, let me see what's happening here. Right. Looking at my calendar here. Next week
is
I have
Monday.
training from 4 to 8. So Tuesday I have a graduation. So I wanted to do the show on Monday at 11 a.m. So we back here Monday at 11. And then we can do the show on Thursday still. So Monday and Thursday next week.
Monday, Thursday. Okay.
So when we get back here on Monday, we're going to integrate this new package now, TCP package, into our CAP. So we could do CAP to CAP communication, at least us sitting next to each other. I think I want to leave the NATs in there.
Okay.
But have it so if we can establish a peer-to-peer connection, use that over NATs.
Oh, so kind of have like an option.
Like we try it first.
Yeah.
Like if we have in the config, I have your IP address, then we're going to establish this, else we use NATs.
Got it.
But if there's an IP address there, that's what we're going to use.
Okay.
Okay. And then if we can get our machines working where NATs isn't involved, then peer-to-peer would support downloads and peer-to-peer would support these sorts of things, right?
Got it.
And then we bring in the Tailscale client and see if we can do this over the internet, still establish a peer-to-peer. I've never played with it. I'm going to start playing with it a little bit with Florin too, but this is like out of my, we might need to bring Florin in on the show for that. And Florin's in Romania, so get a peer-to-peer connection between us and Florin sort of in Romania would be. So when we're ready for that, I'm going to bring Florin in and we're going to figure that out. But
cool.
All right, we did like, shoot, it's 1:30 already. So, but I'm happy with where the code is. So that's good. You saw me code with my Hercules hair today, so that's good. But yeah, that was good.
No, it was cool to see like the actual refactoring and how you just go kind of step by step, move things, play with the idea. Okay, continue
Make
on.
sure it's still working.
Make sure it's working while you're doing it.
Don't
Yeah,
make too many changes. I waited too long to test that. So when that broke, I went, oh man, there's too many changes.
I find myself doing that a lot.
Yeah, no,
You get in the zone and you're just moving,
I
making
know, but then
changes.
you're like, which change broke it, and how much of this I have to roll back? So,
Exactly.
all right, so we're gonna sign this off. I appreciate everybody. I don't know how many people are hanging out today, but appreciate Mohammed hanging out. We got to get Mohammed still on the show. We got to
Yeah.
figure that out.
Maybe we can set that up for Monday. I can.
It's on you, bro. He's not
Yeah,
here
I'll
because of
send him-
you. He
I'll
ain't
send
here
him a
because of
video.
me. So beat
I'll
him
send a
up.
video.
All right, that sounds cool. All right, we'll see everybody. Thanks.